So the first problem in probability, a computer producing factory has only two plants, T1 and T2. Plant T1 produces 20% and plant T2 produces 80% of the total computers produced. 7% of the computers produced in the factory turn out to be defective. It is known that probability of computer turn out to be defective given that it is produced in plant T1 is 10 times the probability that computer turn out to be defective given that it is produced in plant T2. A computer produced in the factory is randomly selected and it does not turn out to be defective. Then find the probability that it is produced in plant T2. So here T1 denotes the plant T1, T2 denotes the plant T2, and D denotes the defective. So as per the statement, it is given probability of D given T1 equal to 10 times the probability of D given D2. If I take probability of D given T2 as the X, then probability of D given T1 will be 10x. Now, total probability, that is probability of defective computer. That is probability of T1 into probability of D given T1 plus probability of T2 into probability of D given T2. Now, when you simplify, you'll get X equal to 1 by 40. Now, as per the statement, so using Bayes theorem, we need to calculate probability of T2 given D bar. That is probability of T2 into probability of D bar given T2 upon probability of D bar. So if you simplify, you'll get 78 by 93. So probability of getting sum 5 is 1 by 9, getting sum 7 is 1 by 6, and neither 5 nor 7 is 1 minus 1 by 9 minus 1 by 6, which is 13 by 18. So as per the statement, probability that 5 comes before 7, that is either 5 immediately or neither 5 nor 7, means 13 by 18 into 1 by 9 or 13 by 18, 13 by 18 into 1 by 9 and so on, infinite terms. So which is 2 by 5. So let us consider the set A as A1, A2, A3 and so on An. Means the set A contains n elements. So the number of subsets of the set A will be 2 to the power of n. Now we are selecting a subset P from the set A because number of subsets are 2 power n. So selecting a subset is 2 to the power of n ways. But we have replaced back the elements. So the set A again contains the same number of elements. After that, again we are selecting a subset Q. So for selection of Q also again 2 to the power of n ways are there. So total number of cases are n of s equal to 2 power n into 2 power n, which is 4 to the power of n. Now for the first problem, P intersection Q is a null set. That means here we have to observe the elements in the intersection. You should not have any common element. Suppose if I consider one element in P, that should not be in Q. Or if I consider one element in Q, that should not be in P. Or the element neither in P nor in Q. That means that there will be 3 cases for a specified element A1. A1 can be in P but not in Q. A1 can be A1 in Q but not in P. Or A1 is neither in P nor in Q. That means for each element you are having 3 possible cases. That means probability that P intersection Q is a null set is 3 power n upon 4 power n, which is 3 by 4 whole to the power of n. So for the second bit, P equal to Q. So total favorable cases are again 4 to the power of n only. Now when P equal to Q means each element has to be in Q, P as well as in Q, or neither it should not be in P, it should not be in Q. Then only it is possible. That is, each element has 2 possibilities. That's why it is 2 power n upon 4 power n. Whereas for the third bit, P union Q equal to A. That means if I consider A1, if A1 has to be in either in P alone or Q alone, or it can be in both the sets. That's why again 3 possibilities. So 3 power n upon 4 power n. Next, P intersection Q contains just one element. That means I can choose any one of the elements. Means there are n possibilities are there. After selecting the one element, then the remaining elements each has 3 possibilities. That's why it is 3 to the power of n minus 1 upon 4 to the power of n. So if 4 squares are chosen at random on a chessboard, find the probability that they lie on a diagonal line. Means on this diagonal, there will be 8 squares. So choosing 4 will be 8c4. So below to this, 7 squares will be there. In this, we will choose again 4, 7c4. Next is 6c4, 5c4, 4c4. Now below and above, it is the same. That's why into 2. Now again to the opposite side. Again entirely we multiplied by 2 upon 64 c4.